Our topic is public key pair authentication and secure cell access. SSH. If you are a network engineer, probably every day you are logging to various network elements, or if you have things in cloud, you access your EC2 instances or any other computing instances, right, from your local machine securely. And the protocol what we use is SSH. Let's discuss what we have in agenda today. So we will try to understand what is SSH. Okay, we will also try to understand how public key pair encryption and authentication support SSH. Then we will look at, are there different type of SSH key? What are the different types of key algorithm we can use? We also try to understand what is the problem this public key pair solving for us. Then we go into a little bit deeper into SSH, and we will look at the client authentication exchanges. When you try to authenticate a server from a client, SSH is a server client protocol. So what happened in there? After that, once we are logged into the server, we will start exploring or taking a deep dive into the various configuration parameters and see what are the options available and try to understand their meanings. How we can enable SSH for a passwordless authentication. That means you don't have to remember passwords, and how you can scale at the same time, right? If there are hundreds of users, or it's a big team, hundreds of users is logging to that server, how you can scale. I'll show you when you spin up a compute instance on cloud, what happened in that case, right? What kind of by default SSH configuration you get, and try to understand that. And finally, we will see everything in action in demo. So before we deep dive into SSH, public key cryptography, right? If you are not familiar with public key cryptography, I have touched base on that in my earlier video, TLS video. You can watch that. But as a refresher, public key cryptography is asymmetric cryptography. That means you need one key to encrypt your data and you need another key to decrypt that, right? So they work in pair. These keys are associated with each other. The key used for encryption is called public key, and the key used for decryption is called private key. Public key can be distributed openly, and private key need to be protected or guarded and kept secure with owner. These key pair have pre-image resistance. That means you cannot derive your private key using public key. So if you are distributing your public key, there is no threat. So that is about public key pair. Now let's deep dive into SSH or try to understand SSH. So prior to SSH, in Unix or Berkeley suite, you have R suite available, which is R login, RSH, even the telnet. So these were the protocol used for remote access and remote login. The only caveat with this, everything you type was sent in clear text over the network. So you can see that if there is a eavesdropper or a man in the middle, they can read all your data without any problem. So it's basically not very secure, right? Then we came into era where not only humans are accessing remotely, there is machine-to-machine communication also happening, right? So if you look at any controllers and its surroundings or environment ecosystem, basically the controllers log into each and every component using SSH because it wants a secure tunneling or secure remote access. So machine-to-machine communication is also prevalent using SSH. SSH is also a founding stone for secure copy protocol. Even the netconf, the new generation configuration management protocol, it is also running over SSH using a different port, of course, and we will talk about that. SSH importance is growing paramount, right? So now let's try to understand SSH in detail. SSH protocol enable cryptographically protected remote system administration and file transfer over insecure network. So you have remote access and file transfer over insecure network. You can do it securely via SSH. Using multiple encryption method, SSH secure the connection between a client and a server, safeguarding the user's command, authentication, and output against unauthorized access. Though SSH stands for secure shell, SSH does not provide a shell. So the name is a little bit misleading. It's a secure shell, but it is not actually a shell. It gives you a encrypted tunnel to the shell of that program, remote program. So you need to think SSH as a security tunnel in transport layer, protecting both password sent to login to remote, and any data. The general mode of SSH is that programmable remote host can run security tunnel. And here is the diagram you can see. So if I have a local host, which is my local machine, and I'm trying to SSH to a remote host or the server, this is what happening. My SSH client will open an authentication request with SSH server, and once that request is successful, we'll have a secure tunnel, SSH tunnel, and SSH server in turn will connect to a shell or command interpreter, and this will talk to application basically. So everything you type in between client and server, they will be encrypted over this SSH tunnel. So now let's talk about, as we touch base on SSH, using SSH very well can use password, but that's not what we want to use. We want a maximum security, and that's where we rely on public key pair cryptography. So what is SSH using key pair? SSH key pair consists of two long series of characters, as I mentioned, a private which need to be kept secret, and a public which can be safely shared, right? And there's purpose is same, to automatically establish an SSH without need to type the password. How keys work? Let's talk about key a little bit. A public key is essentially, it's not a kit. It behaves like a padlock that you can put on your SSH account. When you run SSH keygen utility, we'll talk about the commands later, but to handle SSH, you need a SSH keygen utility. It is available by default when you install OpenSSH. You generate both a padlock and the key that open it. They are denoted at idrsa.pub. So if it has extension of .pub, that means it's a public key, and generally if it is a RSA private key, just a ID RSA. By default, these are the naming convention. So how you can generate SSH key pair? Just as a refresher, first you need to install OpenSSH server on your machine, and this is how you can install OpenSSH server. To install OpenSSH server, and then go and once you install this, you need to enable SSH services and then start SSH service. Once you have SSH services installed, what you want to do, you want to generate a SSH key pair. So here I'm saying that give me a RSA key of length 4096 bytes. So it will generate a key, and it will store the key by default in a hidden directory, .ssh directory. This as a directory is created as you install OpenSSH on your machine. So IDRSA is a public key, and IDRSA pub is public key, IDRSA is private. Then what you can do, you can copy the public key for distribution using pbcopy application command. You may have to install pbcopy. Obviously, if you want to validate your public key, then you need to calculate the fingerprint, and this is you can calculate fingerprint using SSH keygen utility, SSH-keygen -lf and the public key name. It will give you fingerprint of the key, because in SSH message exchange, all you can see is the fingerprint. You cannot see the real public key. A little bit about permissions. So your private key need to be safeguarded. That means you need to have a permission of 600 or so this is other way. Actually, I got it reverse. I'm going to fix it when I will post it. So private key need only RW access for owner, and rest of the things none, while public key can be open and it can have 644. As we are talking about key pair, is there only RSA algorithm available to generate a key pair? Yes, in earlier RSA was the only algorithm, but now elliptical curve ECDSA is a new entry. You can have two types of key pair using RSA algorithm or ECDSA. The both are used to generate a public key pair. That means a public key and private key. So what is the difference between them? To highlight that, ECDSA is a shorter key. Okay, but this shorter key gives you some kind of benefit, or it has some disadvantage. So let's understand that. Both algorithm in question perform about the same time consuming mathematical operation. Thus input size remain the most significant factor of affecting this performance. So you have RSA, which is a longer key, ECDSA, so shorter key input. Comparing two algorithms need to be distinguished between signing a message and verifying a signature. In most practical implementation, RSA seem to be significantly faster than ECDSA in verifying signature, those lower voice signing. So it has like a pro and cons. RSA is very fast or good at verifying signature, but when it comes to sign, make the signature, it is slow, right? So ECDSA is a new entry. It is kicking off, and you will see a lot of cloud-based application. They have now adapted to ECDSA. So now let's understand how secure is this algorithms, right? So in cryptography, we have a concept called security level. Security level is a measure of strength that a cryptographic or a hash function achieves, right? How secure it is, that algorithm. Security level is usually expressed in bits, where n bit security mean that attacker would have to perform 2 to the power n operation to break it. AES 128 is designed to offer 128-bit security level, which is considered roughly equivalent to 3072 bit of RSA. So here you can see, for example, this is we are talking. If we want 128 bit of security, that means attacker need to perform a computation of 2 to the power 128. This is the key length you should choose, 3072, or if you are using ECDSA, then you can stay between 256 and 383. So how much security you want? For that, you need to choose a certain key length type. But again, be aware that longer the key length, if you are achieving more security, your performance may be impacted, right? So we need a very good balance of like performance and security. And if you are wondering where we are mentioning the key length, here, when you generate the key, you say that this is the key length I want. Are these really secure? RSA, ECDSA, with the advent of like so much advancement in computing? Yes, as a side note, threat of quantum computing. Once quantum computing is prevalent, it is an assumption from Shor's algorithm that RSA and ECDSA can be broken in sufficient time frame. RSA and ECDSA can be broken, but the incentive is minimal. If it takes 100 years to break a key, maybe when you have the key, it is meaningless, right? But with quantum computing, it is assumed that using Shor's algorithm, RSA and ECDSA can be broken within time. And I am not well informed on that. That's why I kept provided a Wikipedia link. Go ahead and read it. So we have touched base upon public key cryptography. What are the different variants of key you can generate using RSA and ECDSA? Now in cloud, if you go and spin up an instance, it asks you to download your private key. And when you download the private key, you find it in .pem format. You may start wondering that what is .pem? We know that if it is RSA, then the extension should be .pub. So is it RSA? Is it ECDSA? What is this .pem key? So .pem is not basically a key. It's a format. It can contain anything. It can contain a certificate with public key. It can only contain the public key private. So it's a bucket. You can park the object inside that. And in AWS case, what you receive your private key encapsulated into .pem. So just a side note. Now let's talk about how secure is SSH, because we are talking about encryption. All the data which travels on SSH tunnel, they are encrypted, right? What does encryption does is it actually, when some data must be encrypted, it must also be protected with a MAC or a tag, right? Because encryption protect only against passive attacker, but it is not authenticated, right? So how should I assemble encryption and MAC? For encryption plus authentication, you need two things. You need encryption plus you need a MAC, right? So there are protocols which does MAC first and then encrypt. That means you compute the MAC on clear text. You create a calculate a hash on clear text and append it to data, and then along with hash and data, you encrypt it, right? This is what TLS does. In SSH, what happened? It compute the MAC on clear text, encrypt the clear text, and then append the MAC at the end of ciphertext. That's what SSH does. Encrypt and MAC, because we have only one key. So what we do, we use that key to compute the MAC first on clear text, and then we use the same key to encrypt that clear text and then append them together. So basically TLS uses two keys, but SSH uses only one key. That means attacker need to know only one key. That make a case that it is not as secure as IPsec and TLS, but good enough for remote access. Now we are at a point where we can start discussing about what happened in actual authentication between client and server. So SSH at transport layer provide SSH server authentication, encryption, and integrity protection. It includes negotiation of cryptographic parameters and key. And you will see that in demo, that what happened between client and server, how they negotiate cryptographic parameters and key. During session negotiation, SSH server declare which client authentication method its client may use, while additional option may be supported. Common option including the following are a client password or a public key. So you can say that I am going to authenticate using a password or a public key pair, or a Kerberos ticket obtained from a Kerberos server. So you have a central server which can grant access. You can get a ticket from that and get access, right? Kerberos based authentication, generally called GSA API, and we will talk about GSA API authentication later in the section. A typical SSH client authentication process for the case of client public key. So we are focused on public key authentication, and what happened in public key authentication is a server receive from client that client public key as well as the client signature. So server is going to receive the public key and the signature. Signature is signed by a sender's private key over a pre-specified data, including a session ID at transport layer. Then server perform checks for two conditions. Client public key is available on server already. So it says that, okay, the client is sending me a public key. Do I have that public key available? Yes. And receive signature is valid. So the signature what it received, it try to decrypt it, right? Or unsign it and see that, yes, it is signed by this respective private key. Once these two conditions hold good, the session is established. This is what happened during exchange. We will look that into action. And now we are assuming that we are already in the server. So let's start exploring the configuration. Passwordless authentication, very prevalent, right? That's what we want. We don't want to remember password if you have 100 of servers, or you don't want to reuse the password also on those 100 servers. So basically a passwordless authentication with some sort of central management. That means you change your password one place and it should be affected everywhere. That's the environment you want. And obviously machine to machine communication. Machines cannot input the password itself. So it's always better to have a secure passwordless authentication. This talks about GS API, generic security service application programming interface. The idea is to authenticate the client, typically the machine you are sitting at. Then SSH will pass your credential to the remote server where it is checked, and then you are logged in. GS API, it does a little bit more than just user authentication. So it also does some sort of authorization. If you are authenticated and logged in using GSA API, it by default grant you some level of access to the file server and other things, right? Which is not possible purely with other methods, because you may log in, but then you have to set all the permissions. With GSA API, the permissions are managed using PAM. Okay, so GSA API and PAM go hand in hand. PAM stands for Pluggable Authentication Module and is used to perform various type of tasks involving authentication, authorization, and some modification. Okay, that's just what I mentioned. And this is what you will see on cloud. Any cloud VM, when you log in, you will see you're using your public key, but then your authentication type is set to GSA API and you are using PAM. Because cloud want to perform some sort of identity access management and grant you a role. That's where this type of authentication is most suited. Use case for PAM, we already discussed, right? So if you want to add a new user who can log in with the same privileges, right, you can all do it without going to all individual server. You can do it at central place, and you can implement two-factor authentication and all those things. So basically it's a ease of use for and combining authentication and authorization. All the links are provided. If you want to read more, click on that link, internet article or a research article, and educate yourself more about it. So this document will be available again on SDN Tech Forum website, and all the links what I have mentioned here, I'll put them under the description of this video.